Hello guys, welcome back to the channel. So in today's video, we're going to be looking at what are knowledge graphs and how knowledge graphs are used in the world of AI, machine learning, and data science. Okay, so let's get into it. So we'll first look at what we'll be covering inside of this video so you can make a quick decision whether this video has the content that you need or doesn't have the content that you need, so you don't have to waste your time watching it if it doesn't satisfy your need. But I encourage you to watch it in case the whatever you're looking for is not mentioned within the content that will be covered, but maybe I will cover it. Okay, so let's jump into it. So first we're looking at what's a knowledge graph. What are knowledge graphs and where they're used? Okay, in the world of AI, machine learning, and computer science as general. We'll look at the relation between knowledge graphs and relational database management systems, because knowledge graphs are simply a form of a database. So how do they relate with relational database management system? We'll take a look at that. We'll also look at the applications of knowledge graphs. How are the knowledge graphs used in different scenarios, such as AI, in social media? I'll actually show you a chatbot that I built using a knowledge graph. Okay, that's also using LLM, which is the the GPT-3 Turbo LLM. We'll see how we can connect that with a knowledge graph to create a chatbot. Just stay tuned. We'll also look at examples of knowledge graph tools, like different libraries that are used to build knowledge graphs. And then on number 5, we'll look at the applications of knowledge graphs in RAG systems. So RAG stands for Retrieval-Augmented Generation, which is just a form of knowledge bases for AI models. So for example, let's say we have a LLM, right? So you can connect it with a knowledge base, and you can use a RAG architecture to retrieve information. And you can see how knowledge graph can be used in building such systems. And I'll demo to you an application that I actually have using a RAG system that is implemented using a knowledge graph. I'll show you the whole application. And then we'll discuss upcoming content. I'm thinking of creating some courses and that stuff on RAG and knowledge graph. We'll see if that's going to be coming soon. Okay, so now let's look at knowledge graph. What is a knowledge graph? So I think one of the basics to understand something is not just someone having to use definitions or some phrases from a book or a dictionary, or I don't know, from somewhere. I think the basic to learn is through examples. I'm going to show you an example. Through that example, I hope you get the concept of what a knowledge graph is. Okay, so let's start with social media. Let's start with YouTube. So let's say you go on YouTube and you watch a video on knowledge graph, which is this video right here. And suddenly you might get other video suggestions that, hey, people also watch video on Neo4j crash course. So Neo4j is a library that is used to build knowledge graphs, right? So if you're watching a video on knowledge graphs, you might also be interested in Neo4j, which is a library used to build knowledge graph. You might also get a video suggestion that is saying what is KGs, where KGs stands for short for knowledge graphs. Okay, so you might also get another video that is saying the applications of KGs, which is knowledge graphs. Another video suggestion knowledge graph in AI, how knowledge graphs are used in AI. But you only went to watch a video on knowledge graph, and suddenly you're getting all these other recommendations that relate to it. So how does YouTube know that, hey, a video on Neo4j crash course is related to the current video that you're watching on the knowledge graphs? How does YouTube know that this video, which is knowledge graphs, is related with this video Neo4j crash course? And that's when knowledge graphs can come into play. So using knowledge graph, YouTube can map all these videos in the background, saying, hey, this video has also, the person who watched this video has also watched this video. So if you're watching this video, you might also be interested in this video, right? So these are all applications of knowledge graphs. Okay, so I hope that makes sense. Okay, now let's take an example of social media. I know these days all of us will use social media in some way or some shape, right? So let's say that you go on Facebook and you follow Mr. J, right? You follow Mr. J, you don't know anything about Mr. T, you don't know anything about Tilda, you don't know anything about Hilda, you don't know anything about Jendo. But suddenly Facebook is suggesting to you other friends that you might follow. So it's suggesting to you that you can follow Mr. T as well. You can follow Tilda, you can follow Hilda, and you can follow Jendo. But you don't know all these guys. How does Facebook know that you'd likely follow these guys? Now, what's Facebook, with the data available to Facebook, is able to build a knowledge graph to understand if people who follow Mr. J also follow Jendo. They also follow Hilda. They also follow Tilda. They also follow Jack T. So how does Facebook know this, right? Based on how people are using the platform, right? So maybe Mr. J and Jack T they post similar content. So people who follow Mr. J are likely to follow Jack T, right? So Facebook uses this information to suggest your new friend requests or friend suggestions based on who you follow. Okay, let's take another example. Let's say Snapchat, right? So I'm not a big Snapchat fan, but if you Snapchat, if you follow one friend, maybe you go somewhere and you get the contact of your friend and you start following him on Snapchat. Suddenly you get a friend suggestion that, hey, this is Mr. X or Mr. Y somewhere. You have 20 friends in common. Okay, you don't know Mr. Y, I don't know Mr. X. Why is Snapchat suggesting to me I can follow this guy as well, or as a friend suggestion? Because you have friends in common. And how does Snapchat know all this? It's not all this using a knowledge graph. So it's building a connection between all this data it has available to it. So since you follow let's say your friend is J, right? Mr. J. Since you follow Mr. J, right? Mr. J is also followed by this guy. So you guys might also be might also be friends, even though, so you're like a friend of a friend, right? So this is you right here, and you follow Mr. J. So you can also suggest to you, hey, you can also follow Tilda, you can also follow Jane Doe, or you can also follow Jack T. Even though it never knows you, it doesn't know anything about you, but based on the data and your interaction with it can suggest you, hey, since you follow this guy, you might also know this guy, because you have 20 connections, 20 friends in common. So we are all related. So how does Snapchat know all this? Well, it does all this using a knowledge graph implementation. Okay, let's go and look at another example. Let's take Google. So I'm currently in Nairobi in Kenya. So I'm going to use Kenya as an example. Okay, so let's say I go on the internet and I Google Nairobi, or let's say I Google Kenya. I just type in Kenya, and then suddenly I might get different different suggestions. So I can say Kenya has the capital city, Nairobi. Kenya is a member of EAC, which is the East African Community. Kenya is located within Africa, and Kenya is part of East African Community, or part of the East Africa, part of a country within East Africa. So how does Google know all this? Well, it does knows all this using a knowledge graph. So Google actually has a knowledge graph available to people. If you want to use a knowledge graph, it's called the Google knowledge graph API. You can go and sign up for it, and you can see how Google has access to all this information. So you can go ahead and search for Kenya, and suddenly you're getting all this information about Kenya. So this coming from a knowledge graph, and Google has an API that you can use to see how all this work in the background. So you can see Kenya has a capital of Nairobi. Kenya is a member of the EAC. Kenya is located within Africa, and then Africa is East Africa is located within Africa. So actually it's an error right here. The arrow needs to be turning backwards, because yeah. Okay, so that's an error on my side, but don't worry about that. That's not the issue, the major issue right now. So basically, I hope you understand this concept. Just by searching for one information, you get all this other related information being provided to you. So just by showing you this knowledge graph, and without you having ever to visit Kenya or even heard of the name Kenya, you can write me a whole description of Kenya just with this knowledge graph, right? So you can say Kenya has a capital city of Nairobi, is located within Africa, is part of the East African Community, just by having this knowledge graph, right? So that's how computers are able to understand the relation between different objects and entities within the real world, within the computer. They can use all knowledge graphs to understand the difference between the real world entities. Okay, that's the knowledge graph. Okay, so a knowledge graph is just a database, just like any other database, like Postgres, MySQL. All these are just databases, right? So knowledge graph is just another database that basically stores entities and shows the relationship between these entities. So knowledge graph is made up of three main things. So we have a node, which can be like we can describe any object, like a person, a place, a building. Then you have an edge. So an edge is just that defines the relation between two nodes. And then you also have properties. Nodes can have properties. So let's say we have a person. A person can have name and age. Those are the properties of the node. Okay, so the person node has properties of age, height, weight, and all that. So that's called properties. So edges are the relationships. The entities themselves are called the nodes. Okay, let's take an example. Back to Kenya, the Kenya example we had. So Kenya has capital Nairobi. So this is a node right here, and this is another node, and this is an edge, and this edge is a relation, and the relation has capital. So if I provide this to a computer and ask it, hey, what's the capital of Kenya? So you can see, looking at this knowledge graph, the computer can go ahead, or the algorithm can go ahead and answer this question. Since Kenya has a relationship with another node called Nairobi, and the relationship has capital, so Kenya has a capital called Nairobi. So you can provide, hey, the capital city of Nairobi, the capital city of Kenya is Nairobi, just through this graph. Just an example, simple example of a node, edges, and nodes, another node being connected. Okay, so the direction of these arrows is actually important. You can say that Nairobi has capital of Kenya. No, it has to be Kenya has capital of Nairobi. So the direction of the arrows is very, very important. And Relation can also have properties themselves. So this, you have a relation here called as capital, and this relationship can have relation between Kenya and Nairobi can also have properties, like the size is 10 million, the population size is 10 million, the cost of living is cheap. That's just quote unquote cheap. I hope it was that cheap, but actually a bit expensive. Okay, so we have Kenya and we have Nairobi, and has capital is the age or the relation connecting between them, and you also have the a property of this relation, which is the population size and the cost of living. So now I have this knowledge graph. I can tell, hey, Kenya has a capital city of Nairobi, and which has a population of 10 million, and the cost of living is cheap. So based on this knowledge graph, I can provide that description. That's an example of a knowledge graph. So as I mentioned earlier on, the direction of the relationships are very, very important. The direction of the arrows are very, very important. So you can see Kenya has capital of Nairobi. Nairobi is located in Kenya, right? So that's one relationship. So the direction is very important. You can say that Kenya is located in Nairobi. No, you have to say Nairobi is located within Kenya, because Nairobi is a city within Kenya. Kenya is a country, and Nairobi is a city within that country, right? And so that's the direction of the arrows is very, very important. Okay, so now take a look at this knowledge graph. You can even pause the video. So based on this knowledge graph, you can basically have a brief idea of what Kenya is, in terms of geography, the time zone, national parks in Kenya. You can have where Kenya is located and all that. Okay, just pause the video and try to write a short story about Kenya using this knowledge graph. So it actually should be very easy to do. Okay, now let's go through it. Okay, I hope you pause the video and written something about it. If not, you can pause it right now. Okay, so I'm just back here. So now let's continue. So let's say that Kenya has a capital city of Nairobi with a population of 10 million. Okay, that's just some data I have. It's not actually real. And then Nairobi is located within Nairobi County, which has a time zone of GMT plus 3, right? So if someone asks me, what's the time zone of Nairobi, Kenya? What's the time zone of Nairobi, Kenya? Since Nairobi is located within Nairobi County and has a time zone of GMT plus 3, I can know that, hey, the time zone of Nairobi is GMT plus 3. So this information, we have inferred this information. These are called transitive, right? Transitive ages in mathematics. So because these are all connected, since I know this information, I can relate with this guy here because they're all connected, right? So since I have the time zone of Nairobi County, and Nairobi is within Nairobi County, then I know that the time zone of Nairobi is GMT plus 3. That is called transitive age, right? So we are inferring this information just by having this graph, right? So we can answer, even though we don't have any age connecting the time zone and Nairobi directly, but we can infer this information based on other ages we have, transitive ages in mathematics, as they're called. So I can also say, hey, Nairobi has a national park called Nairobi National Park. So if I'm gonna ask you, what an example of national parks in Kenya? Okay, Kenya, just by looking at this knowledge graph, you can say Kenya has a capital city of Nairobi, and Nairobi has a national park. Okay, so you can say Nairobi has a Nairobi National Park is within Kenya. So even without even knowing all the national parks without having been provided an age between these two nodes right here, because they're connected, right, you can infer that information, which is called a transitive age. Okay, now let's go right here. So we also have symmetric ages. Let's say that Kenya is next to the Indian Ocean, right? So if I say that Kenya is next to Indian Ocean, I don't have to have another arrow going backwards saying the Indian Ocean is next to Kenya, right? We can basically, this is what you call a symmetric age, right? Since Kenya is next to Indian Ocean, then the Indian Ocean is next to Kenya as well. So this arrow can be also we can draw another arrow right here, and we can have the same relation. But since you can just use symmetric, right? Because Kenya is next to Indian Ocean, the Indian Ocean is next to Kenya, the computer can automatically figure that out. So that is called a symmetric age. So that's basically it. So that's basic information that I simply provided you. So if I ask you, if you go on Google and say, let's say you have built a system using this knowledge graph, and you search, where is Nairobi located? So you can see, okay, Nairobi is located within Kenya, and is within the East African, is within East Africa, which is within Africa. So you can see Kenya is a city in, Nairobi is a city in Kenya, which is within East Africa, and East Africa is within Africa. Okay, so Nairobi is an African city located in Kenya, East Africa. So that's it. So you can see how I can provide all that information just by having a knowledge graph. So that's how basically Google is able to know a lot of things about different entities and places around the world. So you can also have an image right here. We can have an image. So if this was a system like a Google, it will also provide you the URL to that image and display that image to you. So good. So that's basically how what a knowledge graph is. And I hope this gives you a simple understanding of what a knowledge graph is. Okay. Now, so we have looked at basically knowledge graph helps computers to understand the different things about objects in the real world, like the attributes, how they're related with each other. Yeah, so this is how YouTube knows which videos to recommend you based on what you're watching. So if you're watching this video, people watch this video, let's say video X, also watch video Y. So YouTube is gonna recommend you this video using a knowledge graph implementation, something like that. Okay, so let's look at some fun facts, which is called ontology. So ontology is a philosophical study, or that studies the science of what is, of the kind and the structure of objects. In simple terms, ontology seeks the classification and explanation of entities. Ontology is all about the object of inquiry. What you see, what you set to examine. Basically, ontology just explains the relation between different objects and the structure of these objects. Okay, and I got this differentiation from Warwick. I hope that's the pronunciation university. They give this really good explanation of ontology. So this what you're doing right here. If I go back here, it says an ontology explaining Kenya and its capital cities and its location, right? Any time zone and other stuff like that. That's ontology. So ontologies are also part of knowledge graphs. Okay. So now let's look at the relation between what's the relation between a relational database management system and a knowledge graph. They all are databases and they all store data. So what's the relation between them? So in a traditional relational database management system, such as let's say Postgres, we have this thing called tables. In knowledge graph, we don't have tables. Instead, we have nodes and edges. We have primary keys and foreign keys in relational database management systems. In knowledge graph, you don't have primary keys and foreign keys. We have edges instead. Okay, which is just the relation between two different nodes. Another difference between a relational database management system and a knowledge graph, it can be this, right? A relational database relations in a relational database management system cannot contain attributes, right? And relations can contain attributes for knowledge graph. So let's go back here and let me just explain what I mean to you. So you can see right here we have relation between these guys, and these guys have properties, right? This relation has capital. You can see we have a property. We have a property called population size, right? In relational databases, we don't have that. We just have primary keys and foreign keys that are connected, that are related with each other, right? So they don't have any properties to those relationships. So in relational database management system, we can't infer information. We can infer information when it comes to knowledge databases, and I show you how to infer information. So for example, if I ask what's the time zone of Nairobi, or what's the time zone in Kenya? Okay, so I know that Kenya has the capital city of Nairobi, and Nairobi is located within Nairobi County, and it has a time zone of GMT plus 3. Then the time zone of Kenya is probably GM3 plus 3, and which is actually correct. So we can infer information, but in knowledge, in relational database management systems, we cannot infer knowledge from relations. Okay, now let's look at some applications of knowledge graphs and where they're used. So knowledge graph can be used in Google, right? Search engines. As for example, we'll talk about the Google Knowledge Graph API, which is used in Google search engines. And if you also go use Wikipedia, we also have the Wikipedia data, Wikidata, which is just a knowledge graph that is used within Wikipedia. Okay, so there's a knowledge graph that is used within Wikipedia. It's also used in knowledge graph can also be used in AI question answering system, which we are through the implementation of Retrieval-Augmented Generation along with LLMs. And I'll show you how I built a project on that, and I'll show you how that's done. It's also used in social media like YouTube, Facebook, Snapchat. All those friend suggestions are coming from knowledge, kind of some sort of knowledge graph implementation. Okay, so yeah, that's some uses of knowledge graphs, and I'll show you how it can be used in AI to build chatbots and question answering system just in a second. So example of knowledge graph tools and libraries that you can use to build your own knowledge graph if you're interested. So the most common one is probably Neo4j. We probably heard about it. Okay, so Neo4j is fast, very fast. This is their own definitions from their website. So Neo4j Aura is a fast, scalable, always runs fully automated, blah blah. And you can see all that information right there. So Neo4j also has this thing called AuraDB, and AuraDB is very similar to MongoDB. So we have MongoDB database, which you can run locally, or you can also have MongoDB Atlas, which is just something that run on the web that you can create a MongoDB collection up there on the web, and then get the keys and then connect to it. So Mongo Neo4j RDB is very similar to that. You also have Neo4j RDB DS, sorry, not DB, DS. In this case is for data science stuff. Okay, so you can read about it. Again, I am not in this video is not in any way sponsored by Neo4j. I just love their products, right? So I think anyone who does a good job needs to be given credit for it. Okay, so the other things right there such as Infinite Graph, Oriented DB, and Jantos Graph. Okay, so I don't want to go into depth about all these other ones because what I really use a lot is Neo4j. So that's why I spend more time explaining to you Neo4j. So these are other alternatives if you want to, and there are so many alternatives out there. Okay, so now let's look at knowledge graphs in building RAG system. So RAG stands for Retrieval-Augmented Generation. So basically, when you have LLMs such as ChatGPT, right, these LLMs are trained on some data, and data is always evolving and getting updated. So you can't always update an LLM with new information very frequently. For example, when ChatGPT came out, I think it was running GPT-3, or I think GPT-3 or GPT 3.5 Turbo, I don't know. And then later on, they moved to GPT-4, which is now the new version. So GPT-4 has more information because GPT-3 has information until I think September 2022. And now we have GPT-4, which has information until I think April 2024. By 2023. So it's April, somewhere around April 2023. So you can see to train these LLMs is very costly and requires a lot of computational resources. So you can train LLMs basing all the time to have frequent updated information. So that's one of the challenges that you're having. So one of the ways to solving is using a technique called RAG, which is Retrieval Augmented Generation. So basically, you can provide these LLMs with some data. Now, instead of using the knowledge that they currently have, they'll look at your data and use your data to answer the question that the user asked, right? Instead of using the data that you are trained on. Okay, so now let me explain to you what this means. So basically, I have a chatbot right here. So you can see this chatbot. It is built on the U.S. presidential, the Union State of the Union address, which the president gave, and I use this data to build a chatbot. And this chatbot, you can basically ask it any question about what the president said within that State of the Union address. So let me just go back here. Let's ask. I just zoomed a bit so you guys can see. Let's ask it what did the president say about NATO. Okay, so in the State of the Union address, the president mentioned something about NATO. So I'm basically asking it what the president said about NATO. Okay, so don't worry. Okay, so it says that about president about NATO. I actually don't have the answer to this. Okay, so I actually programming that if you can't find the answer, sometimes you get these issues, but basically something it works fine. Basically, I ask it the president within the State of the Union address mentioned about COVID. So what I ask it, what did the president say about COVID? So you can see, give me all the information about what the president said about COVID. I don't know why every time I'm recording a video, this chatbot always disappoints me. But basically, I think the president mentioned something about NATO within the speech. So that's why I asked it what the president said about NATO. But it seems not to give me a good result. So you can even ask what the president said about COVID again. Let's see what result it gives me. So just show you that this is working. So let's search what the president say about COVID within the State of the Union address. And the State of the Union address, I have the State of the Union address, and I've built a Neo4j database based on it. So this is the State of the Union address right here, which is this Neo4j database which I have right here. And I'm simply running this in the Neo4j browser, which is this right here. So I can just go ahead and simply say March. This is called Cypher. Okay, so Cypher is a language used by knowledge graph. So I'm just write a simple Cypher code, right, which is let's see if I can zoom in a bit. So March and return n. So let me just go ahead and run this code and let's see what we get back. So now this will return to me all the information that we have about the different things that I encoded. Basically, I just took what the president's speech was about and built a vector embedding. I don't want to go much into depth about this. So I just put a vector embedding about what the president. So you can see this is what the president said, and we simply converted this into an embeddings, right? A vector embeddings. And whenever I ask a question, the question is converted to vector embeddings, and we perform a cosine similarity search with this vector, which we have here, and then finally we get a document that answers the question more. Okay, so this is the knowledge graph right here. So you can see. Let me just zoom in even more. So you can see right here. So you can see this is the parent document and this is a children document. So the children documents are just subsets of the parent document that gives some specific information. So basically, if I ask a question that's very specific to COVID, it's going to return to me. It's going to find a child document that's going to that's mentioned COVID specifically, but at the end of the day, it's going to return to me the parent document, which has more context that I can use to answer the question. Okay. Again, this is not a video to explain to you RAG systems and how they work, so I'm not gonna go into depth about that. For some reason, this is taking a ridiculously long amount of time. I think because I'm recording is really slow. Okay, but basically, if you ask it to return to something like this, the president provided several key notes about COVID. Firstly, they mentioned blah blah, and you can see how all that works. So basically, it's taking a long time to work because I am actually recording. So let me just check if I'm in performance mode. Yeah, I'm in performance mode. I don't know why it's really slow. Yeah, but basically, this is how it works, and that's how you can build a knowledge graph in the future. I have many videos on how RAG systems work. Okay, and I have a whole series, and I'm going to leave some of them in the description of the video, or I'm going to leave a card up. You can check out how to build a system like this. But now I'm also going to create other content about how to implement RAG system using knowledge graphs. Okay, and that's going to be coming in the future videos. Okay, so that's basically, so I'm using this knowledge graph right here to be able to power this chatbot. So whenever I ask the question, it goes into here and finds which document is best suited in answering this question. So you can see these are the different points that the president mentioned in his speech on the State of the Union address. So yeah, that's basically it. So I don't want to take this is taking too long, so I don't want to go ahead and waste your time. But because this is not a tutorial on how to build RAG system, I'm just showing you how it can be implemented in practice. Okay, so I don't know why this is taking. So let me just try to stop this and let's restart this again, and let me refresh this. Let's refresh this and let's see. Okay, so now let me ask it again. What did the president say about COVID? Okay, because in the State of the Union address, he gave information about COVID. So let's see what the president said about COVID. Let's see if I get a response back. Okay, so this is taking a longer time because I'm recording, so things are a bit slow. Okay, because I'm running a lot of things in the background, so unfortunately this is being slow. Okay, and so sometimes can be due to the open AI APIs, or sometimes they request there's so much traffic up there. Okay, now we got the response back. So the president missed several key points on COVID. Firstly, they mentioned the treatment and the highly right blah blah mask and all that. So you can see everything the president mentioned within the State of the Union address, and it's getting all this information from my knowledge graph, which is right here. Okay, and I'll show you how to build this in the upcoming video, so I don't want to waste a lot of time in this. Okay, I'll show you the code and how to get all this built. So that's basically it. In the upcoming content, I'll make a video on how to implement a RAG system with LLMs like the OpenAI's GPT-4 model, and our own RAG system and our own knowledge graph to be able to build such chatbots and question answering systems. Okay, so yeah guys, that's all for this video. Again, if you are interested, you can follow me on other platforms such as Medium, where I write articles about content like this. Again, if you enjoy reading rather than watching these videos, I'm actually convert this video into an article which I'm going to post soon, and if I have it posted, a link will be in the description of the video, so you can check that out. YouTube, codewithprince, right? And then on Twitter, you can follow me on Twitter, aka X, at prince_crumper, and then you can also follow me on LinkedIn at Prince Crumper. Yeah, so guys, that's all for this video. Thank you guys for watching so much. I hope this video was resourceful to you and you learned something out of this video. Okay, so thank you for watching and see you in the next one. Keep safe.